P0302 is a cylinder 2 misfire code. On this F150 with the 2.7 EcoBoost, the truck may idle rough, stumble under load, lose power, or turn the check engine light on. The fault area can be ignition, fuel, air and vacuum, mechanical condition, wiring, connectors, or module input and output control. Don't turn this into a part swap. Make sure the concern is actually present during testing before any module or component replacement is considered. Start with the basic system checks and follow a structured diagnostic approach. Before chasing the misfire, look for anything obvious that matches the customer's symptom. Check for related OASIS or TSB information, and look for previous repairs that may not have been completed correctly. Make sure the battery and charging system are operating correctly, and verify battery SOC is greater than 70% before beginning diagnostics. Then scan all network modules for codes that help you decide where to start. If other codes are present, check what they mean first. Circuit-related codes get diagnosed before system or performance codes, and if several circuit codes are present, look for a shared power or ground issue before going deeper. Next, make the inspections that can catch the simple problems. Check the harnesses for damage, chafing, and routing. Check fuses, circuits, connectors, and component connections. Then look over the vacuum lines, air intake, and hoses for leaks, restrictions, damage, blockage, or routing problems. Check fuel quality for octane, contamination, and seasonal blend, and inspect the fuel system, tank, and lines for damage, leaks, or routing issues. Also check coolant level and quality with the engine at the correct temperature. Check oil level and quality, and inspect the exhaust for damage, restrictions, or routing problems. When you connect test equipment or jumper wires to pins, use Rotunda Flex probes NUD 105R025F or Terminal Probe Kit 418S035 so you don't damage the terminals. Check male to female terminal fit for a strong, consistent connection. Use the mating pin to check normal separation force. A damaged pin will have very low separation force. If the connector shell, pin guide, or retainer adds drag and prevents a fair check on small pins, remove the pin as needed so the fit can be tested correctly. If connectors, pins, or terminals are damaged, replace the damaged pieces. Use the scan tool to read PID input values, output states, and diagnostic states. Monitor the data logger when you need detailed testing without taking the vehicle apart. If an output state command PID is available, use it to command module outputs. Before condemning module control, understand how that module function is supposed to work. Make sure programmable parameters are set correctly. Resolve active DTCs before continuing module diagnosis. Then test hardwired and networked inputs and test outputs. Check for module software updates. When checking module switching circuits, use output state control to activate components. If the output switching works normally, shift your attention back to the module inputs. Do not apply power or ground directly to module switched components with jumper wires unless the exact test directs it. For circuit loading, match the load to the circuit you are testing. Conductor sizes 24 gauge, 0.5 millimeters or smaller are generally used to carry approximately 1000 milliamps, 1 ampere or less. Conductor sizes 20 gauge, 0.8 millimeters or larger are generally used to carry 1 ampere, 1000 milliamps or more. For a power-providing circuit carrying approximately 200 to 1000 milliamps, load it with a 250 to 350 milliamp test light and measure circuit voltage with a DMM while the light is connected. If voltage drops during that loaded test, suspect excessive circuit resistance. For circuits carrying more than 1 ampere, load the circuit with a similar current device like a brake light bulb. A reduction in voltage during loading again points to excessive resistance. Use voltage drop measurement for higher current circuits. For grounds, measure voltage drop while the component is operating or trying to operate. Use an ohm meter only with the battery disconnected. When checking resistance or continuity, expect less than 2 ohms for most small diameter 18 gauge and smaller wires, and expect less than 2 ohms of resistance for most wiring harness circuits. Keep the meter's limits in mind too. A standard DMM ohm meter's low resistance resolution, approximately 0.1 ohm, limits its accurate use to circuits carrying less than approximately 5 amperes. Reverse the DMM leads and recheck. The resistance reading should not change unless the circuit contains a semiconductor. If it does change, the test result is not valid. To check for unwanted continuity to ground, disconnect both ends of the suspect circuit and measure to ground. Resistance should be greater than 10,000 ohms. To check between two unpowered circuits, disconnect both ends of both circuits and measure between them. Again, resistance should be greater than 10,000 ohms. To check for unwanted continuity to a powered circuit, disconnect both ends, turn ignition or run power on, and measure voltage from the suspect circuit to ground. Only back probe when the circuit has to be tested under actual operating conditions, or when voltage drop testing requires it. Normal voltage drop testing should show a small amount of voltage, with less than 5% of circuit operating voltage expected. Do not force test leads or probes into connectors, and use back probes made for that job. Back probing is the wrong test for a single-point voltage check when 0 volts is a possible answer, because you cannot tell a bad probe contact from a true 0-volt result. It is also the wrong test for checking continuity or opens with an ohm meter. For jumper testing, always use fused jumper wires. The recommended universal testing jumper wire fuse is 5 amperes or less, unless the load requires more. Use flex probes or an equivalent connection to protect terminals, but remember, flex probes are not intended to carry high current greater than 5 amperes. Don't repair a circuit by overlaying a new wire until you understand why the original circuit failed. For voltage drop measurement, connect the voltmeter at the beginning and end of the suspect circuit. Operate or try to operate the circuit, and keep polarity aligned with conventional current flow. A 0-volt reading during voltage drop testing can mean bad meter connections or that the component is not turned on. A small voltage drop is normal. In 12-volt circuits, normal voltage drop is usually less than 0.5 volts, with less than 5% of circuit operating voltage expected. Voltage greater than 0.5 volts indicates abnormal voltage loss, usually from high resistance in wires or connectors. For a voltage in, voltage out test, put the negative meter lead on ground or battery negative. Operate or try to operate the circuit, then measure the power side and the ground side of the load with the positive lead. The power side should be within 0.5 volts of battery voltage. The ground side should be greater than 0 volts, but less than 0.5 volts. In that test, 0 volts or source voltage indicates an open circuit. This path does not give a cylinder 2 pinpoint flow. So if these checks do not prove the fault, pause, recheck the earlier diagnostic path, and avoid guessing. Keep the diagnosis focused on what the vehicle is actually doing. Prove the circuit or system fault before making a repair. Then verify the repair and confirm P0302 stays gone. Takeaway: a cylinder-specific misfire still starts with clean basics, solid power and ground testing, and connector checks you can trust. For more diagnostic training, visit stepdiagnostics.com.